Trapping.
Hi dear student, welcome to my channel. So in this slot we're going to learn periodic table of the element chapter 4 KSSM chemistry, and let's jump into the notes and we try to learn first part known as development of the periodic table. Under development of the periodic table, the first person who contribute for the development of periodic table is known as Antoine Lavoisier. He classified the elements into 4 groups, and the groups are known as gases, metal, metal oxide, and non-metal. So here I put metal oxide. The second person is known as John Dominer. He classified element with similar chemical properties in 3 elements, and he introduced the triad law. And the third person is known as John Newland. He arranged the elements according to increasing order of atomic mass, and elements with similar characteristic repeated at every 8. And he introduced the law of octave. 8 elements in one group. And the fourth person is known as Lottermeyer. He plotted the graph of atomic volume against the relative atomic mass, and he found that the elements had equivalent position on the curve of the graph at similar chemical properties. Right, so the next person is known as Dmitry Mendeleev. He arranged the element according to increasing order of atomic mass. He also left empty spaces for the undiscovered element. And the last person is known as a father of modern periodic table is Henry J.G. Moseley. He arranged the element according to increasing order of proton number. He introduced the concept of proton number. Alright, concept of proton number, an atom with the symbol XAZ, and this is known as nuclear number, this is known as proton number. Is the one introduced the concept of proton number in the atom. Okay, so we go for how to memorize the 6%. Alright, so A stands for Antoine Lavoisier. He arranged the element or classify element into 4 groups. Okay, the second person is John Dominer. He introduced the triad law. Okay, and John Newland, he introduced octave law, and the person who plotted graph is known as Lottermeyer. Alright, and the Dmitry Mendeleev arranged the element according to increasing order of atomic mass, and Henry Moseley, he arranged the element according to increasing order of proton number. These are the person who contribute for the classification of elements in the periodic table. We try to do the first question. Okay, which of the following chemists arrange the element according to increasing order of the proton number, and that will be Henry Moseley. And the second question, which of the following chemists arrange the element according to increasing order of atomic mass? Increasing order of atomic mass is known as Dmitry Mendeleev. Alright, we go for question number 2. Which of the following chemists arrange the element in order in the order of increasing atomic mass? Increasing atomic mass, AM. That will be Dmitry Mendeleev. Alright, I try to check the important key points that given in the box. Okay, these are contribution. The following statement refers to the contribution of the scientists or in the development of the periodic table. So I just read this one. Increasing order of proton number, increasing or ascending order of the proton number. That will be the father of modern periodic table, which is Henry J.J. Moseley. Alright, the basic principle of the arrangement of the elements. So we have here group. Okay, this group is refers to the vertical column of the elements in the periodic table, and this group, students must remember, this group is refers to what refers the number of valence electron. Alright, so we go for next one, the horizontal row of element. Horizontal row of element is refers to period. Alright, students must remember, if let's say group is refers to what? Refers to the number of valence electron. So I put here number of valence electron. If let's say the number of valence electron, so here I put valence electron 1, 2, 3, 4, 5, 6, 7, and we have 8. Alright, so it refers to group 1, group 2. So here we must put 13, 14, 15, 16, 17, and 18. Alright, we check period. Okay, and this period also is refers to the number of shells filled with electrons. with electrons. Number of shells filled with electrons. Okay, and now we check the first point. Okay, the element in the periodic table are arranged in the increasing order of the proton number from left to the right. Okay, what is mean by group? So we try to check what is the meaning of group. The group means vertical column of the elements in the periodic table. Element with the same valence electron are placed in the same group. Elements in the same groups will show similar chemical properties. Right, so we try to check the electron arrangement and the number of valence electron, and these elements belongs to what group. So first I'll start with the sodium. The proton number is 11, so the electron arrangement 2.8.1. It has one valence electron, therefore it's from group 1. All right, we check magnesium. It has a valence proton number of 12, so thus the electron arrangement will be 2.8.2. It has two valence electron, therefore it's from group 2. Alright, we try to check aluminium. The proton number is 13, so we try to do the electron arrangement 2.8.3. It has 3 valence electron, therefore it's from group 3. Wrong, we must put group 13. Alright, we check the last one, sulfur 2.8.6. It has valence electron of 6, therefore it's from group, and it has valence electron of 6. If let's say we put group 6 is wrong, we must put group 16. Alright, so we go for period. What is mean by period? And we try to do one short essay question. Period is known as horizontal row of elements. So here I put horizontal row of elements in the periodic table. The elements be in the same period because these elements have same number of shells filled with electrons. For example, if let's say I'll take a sodium 11, the electron arrangement 2.8.1. we try to draw the electron arrangement of the sodium. Have 3 shells filled with electrons, so I put symbol sodium, first shell, second shell, and the third shell. So I try to arrange the electron arrangement. In the first shell it has 2 electron, in the second shell it has 8 electron, and the valence electron will be 1. And we try to check the number of shells filled with electrons. We have first shell, okay, we have second shell, and we have valence shell. Therefore these elements from period 3. Alright, and these elements has how many valence electron? 1 valence electron. Therefore this element sodium is from group 1. Alright, so we try to check the number of valence electron arrangement of the few elements, and we try to predict the period, okay, where the elements belongs to. So I'll start with chloride. The electron arrangements, proton number is 17, therefore the electron arrangement will be 2.8.7. it has total 3 shells filled with electrons, so it has 3 shells filled with electrons, therefore it's from period 3. Alright, we try to check magnesium. The proton number is 12, so 2.8.2. it has 3 shells filled with electrons, so therefore it's from period 3. We try to do for xenon. Okay, it's a group 18 element, so we try to do the electron arrangement of xenon. Okay, 2.8.18.18.8. it has how many shells filled with electron? 1, 2, 3, 4, 5. Therefore it has 5 shells filled with electron, therefore it's from period 5. Alright, we try to answer this essay question. Describe the position of element X in the periodic table, and we need to explain your answer. The first point will be what? The electron arrangement of the element X is 2.8.4. Alright, so next points. The second point, one, element X, okay, as 4. We try to check how many valence electron. 4. Element X as 4 valence electrons in the outermost shell or in the valence shell. Thus it's from group what? We try to check point number 3. Thus element X is from group 14. Alright, and we try to check the number of shells filled with electrons. The number of shells, we have 1, 2, we have 3 shells filled with electrons, so we put the point number 4. Element X as 3 shells filled with electrons. Thus element X from period 3. Alright, so this is how to answer the short essay questions, and student must know how to answer all these questions. Alright, so we move on to the next part. Okay, next part will be under noble gases. All right, noble gases is the elements that are placed in group 18. So we try to check the group 18 element. This is group 18 element, and all these group 18 element is known as noble gases or inert gases. And how to remember all the elements and the symbol? So we try to remember by referring to this one. Okay, E need a knee X-ray. So we refer this one. E need a knee X-ray. So E stand for helium. Helium. Again, Ni stand for neon. Alright, A argon. Okay, K will be krypton. Okay, X will be xenon, and R will be radon. Alright, so we try to check, put all the elements. Okay, so E stand for helium. Alright, helium He. Next one will be neon. Neon symbol Ne. Argon symbol Ar. Alright, krypton. Krypton symbol Kr, xenon symbol Xe, and the last one radon. Radon symbol Rn. All these elements is placed in group 18. So these are the location of the group 18 element. Okay, these are the location of the group 18 element. Okay, we try to answer a few questions. Okay, if let's say the general predictable given with the symbols that not represent the actual symbol, these are the important questions that students must remember. Which of the following element exists as monoatomic gases? If let's say in the exam they ask monoatomic gases, choose the element from group 18, which is answer B. They want elements, that means the elements exist in the form of atom. Explain which element is chemically inert. Also choose the element from group 18, so answer B. Explain your answer. We check here element, the first element which is helium achieve duplet. Alright, the rest already achieve stable octet electron arrangement. Therefore, B. Okay, so how to answer this one? Element B, okay, as achieve stable octet electron arrangement. Therefore, it's very stable, chemically unreactive. And we must know how to the uses of group 18 elements is helium is used to fill in weather balloon. It's also used to fill in diverse gas tank. Alright, diverse gas tank. Again, neon is used to fill in advertising billboard. Okay, airport landing light. Okay, it's also electric discharge through the glass tube contain neon to produce red light. Argon is used to fill in electric bulb to prevent the tungsten filament from burn. All right, okay, and it's also provide inert environment for welding work. All right, we try to check the krypton is used in LASIK treatment, laser light to repair the retina. Okay, laser light to repair the retina is also used in eye speed camera flash bulb. Alright, okay, xenon. Xenon also is used to use in lighthouse. Is used to fill in lighthouse. For the ship navigation, is also used in as a anesthesia, and radon. Radon is used to destroy cancer cells. Alright, so we try to check the physical properties of group 18 element. All these group 18 element is known as colorless gas. They exist as atomic gases. They have low melting and boiling point. They do not conduct electricity. The atomic size when going down the group, the atomic size or atomic radius when going down the group increases. Why this? Because helium is 2. Alright, so it has okay, one shell filled with electron. Neon, okay, first shell, second shell. Neon, the proton number is 10. It has 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. We have 2.8. Okay, the number of the proton number increases. When the proton number increases, the number of shells filled with electrons. Electrons increases, therefore the atomic radius or atomic size increases. Alright, so we go for melting point and boiling point. When the atomic size increases, the melting point and boiling point also increases. Why? Because when atomic size increases, okay, the strength of molecular forces become very strong. the strength of intermolecular forces become very strong. Thus, okay, the more it is required to overcome the forces of attraction. Okay, that's all for basic principle arrangement of element in the periodic table. The father of modern periodic table is known as Henry Moseley. He arranged the elements according. All these periodic table elements are arranged according to what if they ask in the exam. So answer increasing order. Order of proton number from left to right. Alright, so we try to check the meaning of group. The meaning of group is known as vertical column of the element. Vertical column of the elements in the periodic table is known as group. Okay, this group also is refers to what? Refers to the number of valence electrons. Alright, so we try to check period. What is mean by period? Okay, this period is known as horizontal. Period is known as horizontal rows of elements in the periodic table. Okay, now next part we try to label the name of the group of the periodic table. So we try to check group 1. This is group 1. This is group 2. Group 3 until 12 is here. 13. Okay, this will be 14, 15, 16, 17 and 18. We need to name the group 1 element which is known as alkali metal. This is alkaline earth metal. From 3 until 12 is known as transition metal, and 17 is halogen, and 18 is noble gases. So we try to name the group 1 metal is known as alkali. This group 1 metal is known as alkali metals. Okay, next group is group 2 is known as alkaline earth metals. Alright, the elements from group 3 until 12 is known as transition metals. Okay, group 17 is known as halogen. These elements exist as diatomic molecule, poisonous, and we must handle the elements in fume chamber. And this most stable element which exists as monoatomic gases is known as noble gases or inert gases. These elements always exist as monoatomic gases. So we try to check which element exists as monoatomic gases. So we need to choose the element from groups 18. So here in this question, in this periodic table, they give the symbols that not represent the actual symbol of the element. So we choose the element from group 18. So here is the answer. So I put answer B. Which element exists as diatomic molecule? If diatomic molecule, we have to choose the elements from group 17, which is halogen. Halogen always exists in diatomic molecule, which is F2Cl2 Br2 I2. So the elements will be F. Alright, so I put answer F. Okay, we try to check this question. Okay, which state the elements exist as a metal? Always remember metal from group 1 until group 13 is metal. Alright, so why is the group 1 until group 13? This is group 1 element, so this is metal, group 13. So C, D, G, X, H and D is exists as metal. So I try to put the answer for this one, so it will be C. Okay, so our answer C, G, H, okay, X and D will exist as metal. Non-metal exists from group 14, okay, group 14 until group 18 is non-metal. Alright, so we have A, E, F, B. So the answer will be A, E, F and B. These elements exist as metal. Alright, we try to write down the electron arrangement of the elements with a symbol given, not represent the actual symbol. So I try to erase all this. Okay, we try to put the proton number according to Henry Moseley. The arrangement, the elements in the periodic table are arranged according to increasing order of the proton number from the left to right. So this is proton number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and C is 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So we try to check C. The proton number is 11, so the answer 2.8.1. E, the proton number of the E, where is the element E is here, the proton number is given here 8. So E, the proton number Okay, the E, the proton number is 8, so 2.6. F is the proton number of 17, 2.8.7. Alright, we try to determine the position of the elements in the periodic table. So here W is given, so the proton number is 19, so we try to check 2.8.8.1. It's from group what we refer the valence electron is from group 1. And period what it has how many shells filled with electron 1 2 3 4. It has 4 shells filled with electron, therefore it from period 4. Alright, we checked element K. This is not potassium, this is symbol. So element K 7, so 2.5, so it has a 5 valence electron, therefore it's from group 15. And it has 2 shells filled with electron, therefore it's from period 2. Alright, we check Q. Q with the electron arrangement of 2.8.8. It has 8 valence electron, therefore it's from group 18, and it has 3 shells filled with electron, therefore it's from period 3. Alright, we try to check the last part of this question, how to write the symbol of ion. So what is ion? Ion is known as charged particles. Alright, so we have 2 types of ion. Number 1 is known as cation. Always remember cation is known as what ion? Remember the T is positive ion. Cation is known as positively charged ion or positively charged particles is known as cation. And remember group 1 until group 13 they exist as metal. Metal will always form cation, which is positive ion. How they form the ion? By donating their valence electron. So we try to check the electron arrangement of C. The electron arrangement of C is 11. So we try to check the formula of the ion. C, element C is 11, 2.8.1. So we check the valence electron. The valence electron is 1, therefore it's from group 1. Group 1 is considered as a metal. It will form what ion? Cation. So I put here C positive, and we try to remove. It will donate the 1 electron, so I put the 1 electron here, C1 positive. So we remove the 1. Alright, so remove the 1, so C positive. For example, I take here sodium 2.8.1. The 1 disturbing the stability of the sodium atom, thus sodium atom will donate the 1 electron here. It will loses 1 electron and form sodium ion 2.88. It will achieve stable octet electron arrangement. Alright, so this is the formula. So we try to check the next one, magnesium 12. Okay, it has electron arrangement 2.8.2. When it has valence electron of 2, the valence electron is 2. Okay, the valence electron 2 refers to group 2. Group 2 exists as metal. Metal will form cation. So how to do the formula? Cation is a positive ion, take the 2, put in front. So this is the formula of the ion. Okay, we try to do for N ion. N ion is known as, alright, so negatively charged ions or negatively charged particles. This N ion, group 14 until group 17. Group 18 is noble gases, stable, they do not share, donate or gain the electron. Therefore group 14 until group 17 is considered as non-metal. They will do what? They will accept electron or receive electron to achieve stable octet electron arrangement. Octet means their valence or outermost shell fills with 8 electron. We try to do few example. If let's say I have an oxide atom O, the proton number is 82.6. Alright, so when we check the valence electron 6, the valence electron 6 refers to group 16. Group 16 is not considered as non-metal. Not metal will form N ion. So what is the formula of oxide ion, negative ion? We have 6 plus 2, it will receive 8, become 8. 8 is stable octet electron arrangement. Take the 2, put in front of the negative charges. So I still don't understand. We try to do another example. Chloride ion 17, chloride atom 17, the electron arrangement 2.8.7. okay, when the valence electron is 7, we try to check the valence electron is 7, so it refers to group 17. Group 17 is considered as a non-metal, and non-metal element will form N ion, negatively charged ion. So we try to do the chloride negatively charged ion. Its valence electron is 7. It will receive 1 electron to achieve stable octet electron arrangement. Take the 1 electron, put in front of the C. So 1 no need to put, so the formula will be C L negative. We try to check another element, nitrogen 7, 2.5. Okay, so this valence electron 5, the nitrogen atom consists of 5 valence electron, so therefore it's from group 15. Group 15 consider as non-metal. Non-metal will form N ion, negatively charged ion, so we try to put negative ion. So check the valence electron 5, nitrogen atom will receive 3 electron to achieve stable octet electron arrangement. So take the 3 electron, okay, put in front of yours. This is the formula of the ion. The electron arrangement of ion is 2.8, already achieved stable octet electron arrangement. Therefore we try to answer this question. Alright, so the electron arrangement of C is 11, so 2.8.1. Therefore this is considered as metal. Metal will form cation. So what is the formula of this ion C? It will donate 1 electron. So we try to check G. The electron arrangement of the G is proton number of G is 20. So I try to do the electron arrangement 2.8.8.2. Right? 2.8.8.2. Okay, G is 2.8.8.2, so the valence electron is 2. The valence electron is 2. Okay, when valence electron 2 is belongs to group 2. Group 2 is considered as a metal. Metal will form a cation, so G positive. Take the 2, put in front here. Alright, we try to check D. D from element group 13. Okay, group 13 element, the electron arrangement 2.8.3. It has 3 valence electron. It has a 3 valence electron. When 3 valence electron, it will form cation. So I put positive here. How many electron will be donated? Okay, take the 3, put in front here. Alright, we check the last one, F. F, the proton number is 17. Alright, the proton number is 17, so I put here the proton number is 17. 17 is considered as 2.8.7. That means the F has 7 valence electron. When 7 valence electron, it belongs to group 17. Group 17 is non-metal. It will form N ion. N ion means negatively charged ion. So the valence electron is 7. It will receive 1 electron to achieve stable octet electron arrangement. Take the 1, put in front. So 1 no need to put. So the formula is F negative. Alright. So we try to check the next part. Okay, group 1 alkali. Group 1 metal is known as alkali metal. So these alkali metals because they react with water to form alkaline solution. So this metal react with water to form alkali solution or alkaline solution and hydrogen gas. Okay, elements in group 1 because they have 1 valence electron. All right, the physical properties of group 1 elements, so we have lithium, sodium, potassium, all that. Okay, the physical properties of all these elements, they have a shiny and gray color metal, and they are known as a soft metal, can be cut by using knife, can conduct electricity, and they are kept in paraffin oil to avoid contact with oxygen and water. Alright, we go for when going down the group 1 element. So lithium, the proton number is 3, sodium proton number 11, potassium proton number 13. The atomic radius will increases. The atomic radius will increases, and next point will be the density. When going down the group, the density also will increases, and the melting point and boiling point will decreases. This is due to the weaker attraction force between the nucleus and the electron shell. And when going down the group 1 element, the reactivity will increases, and the electropositivity also will be increases. The meaning of electropositivity is known as tendency of an atom to donate its valence electron and form a cation. The easier an atom to release its valence electron, the higher the electropositivity. Alright, we go for next point. Okay, explain there's a changes that only occur when going down the group 1. The first changes is atomic radius. The lithium atomic radius is smaller, potassium is bigger, potassium is the biggest. Why? Because the atomic radius will increases. Okay, why? When going down the group 1, the proton number increases, and the number of shells filled with electrons also increases. We try to check for lithium. First shell, second shell, 2 electron and 1, 2.1. The electron arrangement is 2.1. We check for sodium, Okay, we have 3 shells filled with electron 1 2, so here we have 2.8 and the valence electron is 1, and we try to do for the potassium first shell, second shell, third shell and fourth shell. Alright, so this is 2.8.8.1, so the number of shells filled with electrons also increases as the proton number increases, therefore the atomic radius or atomic size will increases and we going down the group. Alright, we go for the explanation for the reactivity. Okay, I'll explain there's a changes occur. Okay, when going down the group 1, reactivity will be increases. Which one is more reactive is potassium. Okay, why? Because when going down the group, okay, so our first point will be the proton number increases. When the proton number increases, the distance between the nucleus and the valence shell getting further apart. Alright, the distance between nucleus and the valence shell getting further apart, the nucleus forces of attraction towards its valence electron getting weaker. Thus potassium easily loses its valence electron to achieve stable octet electron arrangement. Alright, so electron arrangement, we try to check. Okay, look at this structure lithium. So here we have a nucleus. The nucleus has the tendency of to pull the electrons and to hold the electrons. So here we have a nucleus, and as the proton number increases and the number of shells filled with electrons increases and the distance between the nucleus and the valence electron getting further apart, thus potassium, the nucleus forces of attraction is weaker. When nucleus forces of attraction is weaker, 2.8.8 is the electron arrangement. Potassium, the size is bigger. When the size is bigger, potassium can easily loses its one valence electron. Okay, the one valence electron to achieve stable octet electron arrangement. Therefore, this potassium is very reactive compared to sodium and lithium. All right, so that's how we try to answer this question. When the two element is given not represent the actual symbol from the group 1, okay, we try to answer which element is more reactive or which element is electropositive. So we call answer 1. Okay, as we know, when going down the group 1, reactivity increases. All right, so Y is more reactive than X. Okay, because atomic size of Y is bigger than the X. Nucleus forces of attraction, or the attraction forces of nucleus towards its valence electron, okay, is bigger. So here I put nucleus forces of attraction of atom Y towards its valence electron is weaker than atom X. Thus, element Y or atom Y easily loses its valence electron to achieve stable octet electron arrangement. We try to answer this question together. Okay, I'll try to look at this periodic table. Okay, and try to read the question. So between which element C and G, which is most reactive or more reactive? So our answer when going down the group 1, reactivity. Okay, reactivity will increases. So element G, okay, more reactive than element C. Why? Because the atomic size of element G is bigger than the element C. The forces of attraction between the nucleus and the valence electron of element G is weaker than the element C. Thus, element G easily loses or donates its valence electron to achieve stable octet electron arrangement compared to element C. So we already score 3 marks here. Alright, we can move on to the next part. Okay, next part we try to do the Amkali experiment regarding the reaction of chemical properties of group 1 element. Group 1 element, so we must remember all these group 1 element can react with halogen H. Okay, they can react with oxygen. All right, they can also react with water, so they have basically HOW, how reaction. So we try to go for first reaction with water. If let's say group 1 alkali metal is placed on the surface of water, we will get a alkali solution and also hydrogen gas. Right, so we try to check this problem statement. The problem statement for this one, so we will take a lithium. sodium and potassium. Small pieces of sodium, lithium or potassium will be cut. We will be put in the water, surface of the water carefully by using forceps, and we try to observe the changes that occur. So in this experiment, the problem statement will be how does the reactivity of alkali metal element with water changes when going down. Okay, how does when going down the group 1. Okay, then we must put question mark. All right, the manipulated variable, the factor that we change purposely, is known as type of alkali metal. So I put type of alkali metal, and the responding variable will be reactivity of alkali metals towards water. So alkali metals towards water, and the constant variable will be size of alkali metal. We will take a small size of alkali metal and we try to put on the surface of water, and the hypothesis for this experiment will be when going down the group 1, the reactivity of group 1 element with water increases. This is the hypothesis. All right, the material that needed small pieces of lithium, and we need the sodium, we need the potassium, distilled water, filter paper, okay, and distilled water, water, filter paper, and red litmus paper. All right, so we go for glass straw apparatus that needed glass straw, knife, forceps. Okay, the procedure will be small piece of lithium is cut by using knife and forceps. The paraffin oil that present on the surface of the lithium is dried by using filter papers. Alright, so next we go for the lithium is dropped. We must put this word carefully onto the surface of water in the glass store using the forceps. The observation are recorded. Alright, the solution that formed is tested with red litmus paper to see whether the solution produced is alkaline or acidic, and the step 1 until step 5, okay, are repeated using lithium. So here we use using sodium and potassium to replace the lithium metal. All right, these are the procedure that we must remember. We try to go for the observation. For the lithium, the observation given move slowly, here move very quickly, and on the surface of water with each sound a colorless solution which turn the red litmus paper into blue color. And the next one they give for the sodium, okay, move very quickly, produce each sound, okay, the red litmus paper turn into blue. So we try to check for the potassium. Okay, for potassium it will move vigorously with lilac flame. It will produce a lilac flame or purplish color flame on the surface of water, produce each sound, and pop sound is heard, and a colorless solution which turn the red litmus paper into here blue. All right, blue is formed. All right, okay, we try to do the equation. Okay, lithium react with water, H2O, so we will get a lithium hydroxide and it will release hydrogen gas. Balance the equation, I'll put 2 here, so hydrogen 2 here 2 4, so hydrogen 2 times 2 4. So I try to go for lithium 2, lithium 2. All right, so the hydrogen will balance, oxygen also balance. We try to do for the sodium react with water, we will get a sodium hydroxide alkaline solution and hydrogen gas will be produced. Put 2 here, 2 here, 2 here to balance the equation. Potassium react with water, we try to check the product will be potassium hydroxide and water. Try to check the number of hydrogen atom on the right hand side. We have 1, okay, here we have total 3 hydrogen, 2 plus 1 3, and here the number of hydrogen atom on the right hand side is total 2. All right, so this is even number, so the even number odd number we make it even, I times 2, so I make it the total number of hydrogen atom 1 2 3 4, then I times here hydrogen atom 4, so at the right hand side hydrogen atom 4, and the next step we need to balance the potassium 2, that's all. Oxygen will balance itself. All right, so we try to do the operational definition for the reactivity of the metal. So what done in this experiment, we take a core, we fill up with the water, we cut a small piece of group 1 metal or alkali metal. So in this case I take alkali metals, I don't want group 1 metal, so the small piece of alkali metal is placed on the surface of water carefully. So how to do what done in this experiment? When a small piece of alkali metal is placed on the surface of water. This is what done. What is observed? The alkali metal, the alkali or an alkali metal that reacts vigorously with water is the reactivity of metal. So what done will be a small piece of alkali metal is placed on the surface of the water. This will be our what done. And what observed will be here. The alkali metal that reacts vigorously with the water is known as reactivity of metal. This will be what observed. Alright, so we try to check the next part. Okay, alkali metal also will react with oxygen. So this group 1 metal will react with oxygen to form a metal oxide. Right, so we try to check the first question. If lithium react with oxygen, so we will get a what product? We try to take out the ion lithium, group 1 metal, it will form Li positive, Na positive, K positive. So I take out the lithium ion and oxide ion, I join them together, oxide ion. So what I will get? Li2O, lithium oxide. Alright, so we try to balance the oxygen, so I put the oxygen here 2. So when I put oxygen, become 2 oxygen balance. Lithium 2 times 2, 4. So I put 4 in front of the lithium. We try to do for the sodium react with oxygen. So we try to get the product. So here we will get a sodium ion. Here I will have an oxide ion. So the formula will be Na positive, O2 negative. So here charge value 1, charge value 2. When we do crossing, so 2, 1. So the formula will be Na2O. Alright, how to balance the equation? I will balance the oxide first. So here oxide 2, here oxide 1. So how to balance? I times in front 2, so oxygen balance. Now I check the total number of sodium atom on the right hand side. 2 times 2, 4. So I put 4 here. Same goes to the potassium. Potassium react with oxygen. So we will get the symbol K2O, balance 2 here. Oxygen balance. So potassium 2 times 2, 4. So I put 4. Okay, in this reaction, how to do the observation? So basically students must remember, alright, so student must remember all these is known as metal oxide. Okay, so I erase all this. So this metal is known as metal oxide. Alright, this is known as a base is a metal oxide. Alright, this is known as a base and this is known as a metal oxide, and this is a white color solid. Okay, and this metal base is soluble in water. Okay, soluble in water. If let's say I take a sodium oxide dissolve in the water, so the product that we will get is sodium hydroxide. Balance the sodium 2. Alright, so I put this 2. If let's say I take a potassium oxide dissolve in the water, so what product we will get? Potassium ion, oxide ion, hydrogen ion, hydroxide ion. During chemical reaction, this one will join, so we will get the potassium hydroxide and water molecule will be here. Always remember, so here we already have A plus B, okay, here C and B. When the B is repeated, just erase this one. Alright, so the product will be potassium hydroxide. How to balance the equation? Balance potassium 2, I put 2. Hydrogen 2, so hydrogen 2 balance. Oxygen is 1 plus 1, 2. Oxygen is 2. So the equation is balanced. And the solution that we obtain is known as alkaline solution or alkali solution. It will turn the red litmus paper into blue. And as we know already, when going down the group 1, lithium, sodium, potassium, students must remember the group 1 metal. When we going down the group 1 metal, reactivity increases. Therefore, lithium is more reactive, potassium is more reactive compared to the lithium and sodium. So here, the observation will be lithium burns slowly with what color flame? Lithium burns slowly with a red color flame. Alright, so I put here with a red color flame. Produce white solid that dissolve in the water and produce a white color solid that dissolve in the water, form a colorless solution which turn the red litmus paper into what color? Into a blue color. Alright, so into blue color. Alright, next one, potassium. Potassium burns with what color? Burns very quickly. Burns we put quickly. Alright, so burns quickly. with yellow color flame produce a white color solid. The white color solid dissolve to produce a colorless, okay, colorless solution, which turns the red litmus paper into blue. All right, so potassium burns very rapidly or vigorously with a lilac flame, produce thick white fume and a white solid. The white fume and white solid both dissolve in the water, form a colorless solution, which turn the red litmus paper into the blue color. Okay, these are the observations that students must remember. All right, we go for next reaction with halogen chlorine. All right, group 1 metal can react with halogen to produce a salt. All right, we try to do the equation. First equation, lithium, group 1 metal, and chlorine. Chlorine, if let's say student put like this, wrong. If student put, the answer is wrong, because chlorine is halogen. Okay, halogen is exists as atomic molecule. Therefore, the student must put Cl2. When reaction occur, we will get the lithium chloride. Balance chloride 2. So here I put 2, lithium 2, lithium 2. So I still don't understand how to do, how you doing very fast. So we go for sodium react with chlorine. So what product you will get? Take out ion, sodium ion, chloride ion during chemical reaction join. So this equation no need to balance. Why? Because the charge value 1 1, okay, same value. So here you put what, sorry, this equation need to balance. Okay, so sodium chloride. So how to balance the equation? So here chloride 2, so I put 2, sodium 2, sodium 2. All right, we do the next question is potassium react with chlorine. So I get potassium chloride, balance the chlorine 2. So I put 2 here, chloride 2, potassium 2, potassium 2. And this substance is known as lithium chloride, sodium chloride. All this is known as a salt. All right, salt is a white color solid, and they are known as soluble in water. They dissolve in the water with the pH value of 7.0 neutral, and they form a colorless solution. And as we know, the potassium reacts more vigorously in the water. So lithium in the chlorine gas. Okay, lithium burns slowly with red color flame, produce a white color solid that dissolve in the water to form a colorless solution. And potassium burns brightly with yellow flame to produce a white color solid. And the last one, potassium burns with vigorously. Okay, it burns vigorously. Okay, or with very bright flame. Or so we can put burns with very bright flame. Okay, what flame? Lilac flame, and produce a white color solid that dissolve in the water to form a colorless solution, and it is a pH value of 7. All right, we move on to the next part, transition metal. Transition elements start from group 3 until 12. All these elements is known as transition element, and these elements is very special, and they are located from group 3 until group 12 of the periodic table. And all these transition metal from group 3 to all the element in the from group 3 to group 12 is transition metal, except zinc, because zinc only have one oxidation state, so zinc is considered not a transition metal. And the physical properties of these transition metal all exist as solid except mercury. Mercury, the symbol Fg, exists as liquid at the room condition. They have a shiny surface, they have high tensile strength and density. Alright, and they have high melting and boiling point compared to non-transition metal. They are good conductor of heat and electricity. Alright, we move on to the 4 special characteristics, or basically 3 special characteristics of transition metals, but I include 4 also here. Alright, it shows the first special characteristic of transition metal. Okay, we have 4 special characteristics of transition metal. Number 1, start with, shows different oxidation number. So different oxidation number, or we can refer as it also shows more than one oxidation number. So what is mean by oxidation number? It refers, this oxidation number is refers to the positive or negative charges. Positive or negative charges carried by the particles. For example, if let's say the ion with the formula of Na positive, Mg2 positive, okay, Cr3 positive, alright, 3 positive, okay, I'll take a transition metal copper to ion. Their oxidation number here positive 1, positive 2. We refer the charges carried by the particles, so this will be positive 3 and positive 2. Okay, that is refers to the oxidation number, and transition metal shows different oxidation number. The second special characteristic, transition metal form colored ions or colored compound. Right, so next one, they also form a complex ion, and these are some of the transition metal also act as a catalyst. It's used to speed up the chemical reaction by lowering the activation energy. So let's start with the first special characteristic. Transition metal shows more than one oxidation number. For example, iron, we have the formula iron, this formula Fe. It has the oxidation number of positive 2 and positive 3. The formula of the ion of iron, it can form two different ion, Fe2 positive, Fe3 positive. Therefore the oxidation number positive 2 and positive 3. Copper will form copper 1 positive, copper 2 positive. Therefore we have a positive 1 and we have positive 2. That's why when we name the copper ion, so we have to name copper, we have to put the Roman number 1 ion. If we want to name the copper 2 ion, so we have to state the oxidation number in the form of Roman number copper 2 ion. Alright, so next one, nickel. Again, nickel Ni2 positive, and we have one more Ni3 positive. The oxidation number positive 2 and positive 3. Chromium Cr3 positive. Alright, chromium we have a 3 positive, and chromium we have a different ion, so it has a 3 positive, Cr3 positive, and also it has a 3 positive and positive 6. Alright, positive 6. Alright, so next one, we go for act as catalyst. Alright, so it will act as catalyst. Some of the transition metal also can act as catalyst. Arbor process is a production of ammonia. Okay, ammonia is a NH, is a weak alkali, is used as used to prevent the coagulation of latex, used as to make a fertilizer. Okay, this ammonia, in the production of ammonia, catalyst iron from transition metal is used as a catalyst to speed up the reaction production of ammonia. Contact process is a production of sulfuric acid. It's a production of sulfuric acid. In this process, we need a vanadium 5 oxide, the formula B2O5, to speed up the reaction. Osford process is a production of nitric acid. In this process, we need the platinum as a catalyst, Pt. Hydrogenation is a production of margarine. If let's say we take a palm fruit, okay, palm fruit can be converted into margarine. Alright, this can be converted into margarine. So in this process, we need the catalyst nickel. Alright, nickel can be used as a catalyst in the production of margarine. Alright, we go for next special characteristic of transition metal. They also can form colored ions and colored compound. Right, we check with the colored ion. So this transition metal iron 2 ion, the formula will be Fe2 positive, nickel Ni2 positive, chromium Cr3 positive. All these is known as a green color ion. So we have a 3 green color ion. All these will form a green color ion, green color ion, green color ion. Okay, and copper 2 ion, the formula of the copper 2 ion, Cu2 positive, and this copper 2 ion is a very special, it will form a blue color ion. So this is a blue color ion. Manganate 7 ion is a purple color ion. Alright, so it's a purple color ion, so take a purple. Alright, it will form a purple color ion, so formula MnO4 negative, it is a purple color. Alright, dichromate 6 ion, okay, Cr2O72 negative, it will form, the O stand for orange color. And manganese 2 ion, Mn2 positive, it will form a light pink color. Alright, it will form a light pink color. Alright, next we go for complex ion. This complex ion, we have a few complex ions that we must remember. The naming method is totally different than we name the normal ion. So in order to name this one, so we try to check the name of the complex ion, that pronunciation that we use for the complex ion. Iron 2 ion, when form complex ion, we have to call ferrate 2 ion. Alright, so next one, if let's say iron 3 ion is called ferrate 3 ion, and Cu2 positive or copper 2 ion is known as cuprate 2 ion. Alright, so if water molecule, we will call aqua, and this one is amine. amine molecule, and cyanide ion is Cn negative. Cn negative we will call cyano ion. All right, so we check the next one, how to name this compound. So we try to check this one. All right, prefix and value. Okay, if let's say 1 we call mono, 2 we will call di, tri, okay, 4 we will call tetra, 5 we will call penta, 6 will be hexa, and the 7 will be octa. And we try to check the name of this complex ion, the first complex ion. So I try to do here. So we have Fe, Cn, and 6, then open bracket. Okay, so here they put 4 negative. Okay, 4 negative. I try to find the oxidation number of ion here, whether they use ion. We have 2 ion, Fe2 positive or Fe3 positive. I don't know which ion, so I will label as X plus cyanide ion. The formula of the cyanide ion, Cn negative, it has 6, so 6 times negative 1. Okay, when we sum up, we take the oxidation number of negative 4, so we put here. So X plus 6 times negative 1, 6 times negative 1, we sum up, we should get negative 4. So X minus 6 will be negative 4. X will be, when bring here, negative 4 plus 6, and that will be positive 2. So the ions that present here, Fe2 positive, and the name for this ion is known as complex ion ferret 2 ion. And we have a Cn negative ion. We have a Cn negative ion. The Cn negative ion we will call we will call cyano, and we have a prefix here. This prefix is 6, so the 6 is stand for hexa. So we try to name this ion. If FeCN, okay, FeCN 6, close the bracket, here they put 4 negative, the name of this ion is called hexacyanoferret 2 ion. Alright, so we try to put here the name of this ion is known as hexacyanoferret 2 ion. We try to name the second ion. So this is the formula of the ion given. I don't know what is the formula of the ion produced, because ion have more than one oxidation number, okay, which is Fe2 positive, or we don't know Fe3 positive. So how to calculate, we don't know this one, so I make it Fex. Plus we have cyanide ion, Cn negative, so I put here Cn negative. We have how many? The prefix value, check the prefix value is 6. That means we have 6 cyanide ion. When we sum up, we should get the negative 3. So I put here negative 3. Alright, then we check here X plus 6 minus negative 1. Alright, so 6 negative 1 times only equals to negative 3. So X minus 6 is negative 3. X will be negative 3 plus 6. So the X value is positive 3. That means the ion present here, Fe3 positive, and the complex ion name is known as ferret 3 ion. And we have a Cn negative ion. The name for this one is known as cyano, and the prefix value is 6, so 6 stands for hexa. So when we merge this together, the name of this ion will be hexacyanoferret 3 ion. So the name will be hexacyanoferret 3 ion. So we try to answer this question together. So this will be hexacyanoferret, okay, 3 complex ion. And here we try to do some changes here. This is known as, okay, 2 negative, and we try to do this try to name this complex ion. So I don't know what is the oxidation state of copper ion, so Cu positive or Cu2 positive. First I need to find the oxidation number, so I make it X plus the chloride ion. We have chloride ion and we have 4 prefix value, then the oxidation number is given negative 2. X minus 4 times negative 1, negative 2. X will be X minus 4, negative 2. So I bring here X, okay, negative 2 plus 4, and this will be X will be positive 2. That means the ion present here is cuprate 2 ion. Alright, so cuprate 2 ion, and this is stand for chloro, and the 4 prefix value is tetra. So the name of this ion, tetrachlorocuprate. Tetrachlorocuprate 2 ion. Right, so we go for the last part. We try to answer the question based on here. So all these transition element, okay, will start from group 3 until 12. all these element is from year to year will be our transition element. Student must remember the 4 special characteristic of this transition element. It start with we do the first question, which of the elements form colored ion? That will be transition element. We just choose any element from transition metal. And which element have different oxidation number or more than one oxidation number? That will be transition element. State the industrial uses of element B. Some of the elements from transition element, they act as catalyst. Okay, we have total 4 industrial process. Arbor, the name of the catalyst will be iron, and we have a contact process. The name of the catalyst vanadium 5 oxide. We have a Oswald process. The name of the catalyst will be platinum. And the last process is known as hydrogenation production of margarine. The name of the catalyst will be nickel. Which element is a transition element? So we choose any element from group 3 until 12, so year B. State 4 special characteristic of elements that from group 3 to 12, this element is known as transition metal. They have more than one oxidation number, and these elements form, okay, these elements form colored ions or compound. They also form complex ion, complex ion, and some of the transition elements or metal, they act as catalyst in certain chemical process. And that's all from me. Thank you very much. Thanks for watching my YouTube channel.